Hello everyone. In this video, I'm going to present you the overview of Delta DVP series PLC. Under DVP series PLC, there are many models are there, under which I'm taking the SS2 model PLC. Okay, DVP series SS2 model PLC. Okay, right. So if you see the picture of a DVP SS2 model PLC, so then it will be looking like these. Okay, so if you observe the first diagram, DVP 14 SS2, right? So this PLC is a Delta make PLC, and in Delta make also you are having a different series PLCs. So once I will show you in a Delta website. See here. So if you go under products, under which industrial automation, so under which programmable logic controllers. Okay, so in Delta company, there are different series PLCs are available. So which are AH series, then AS series, and DVP series. So these are the three types of series which are available in Delta PLC, under which I'm going to give you a small overview about the DVP series PLC. Okay, so under this DVP series PLC also you are having different model numbers. Okay, so DVP EH3, DVP ES2, DVP ES2, DVP EC3. So like this you are having uh, different model numbers. Okay, under DVP series also you will be having EH3 series, ES3 series, ES2 series, right? So these all are the standard type CPU. Okay, so on slim type CPU, under which you are having SV2, SX2, SX, SA2, slim expansion module, SS2 series. Okay, so out of all these I'm going to present you this series, which is DVP SS2 model PLC. Okay, see here. So the first diagram. So this is the DVP series and model number is SS2. Okay, DVP series SS2 model. Now here this 14 represents the total number of inputs and outputs together. Okay, so 14 here, if you observe the pins on this PLC, it is having almost X0 to X7. X0 to X7 are the digital inputs. Okay, total you are having 8 digital inputs, and Y0 to Y5, these are the digital outputs, and total you are having 6 outputs. So 8 plus 6, which is 14. So right, this 14 represents the total number of input and output points, you can also say in, or you can say terminals. Okay, so this is one model of DVP series 14SS2, right? So this is a transistor logic PLC, right? So which means that inside this PLC, for the contactors are made up of transistors. The transistors may be PNP type or NPN type. Okay, so now if you observe the second one is also the same DVP 14SS2 model. So but this PLC is a relay type model. Okay, the first one is transistor logic model, and the second one is the relay type model. Okay, so in this relay type model, these terminals Y0, Y1, the inputs and outputs, these are made up of relays instead of transistors. Okay, that is the only difference. So one PLC is transistor logic, another is the relay logic. Okay, the model number and number of input and output devices will be same for these two PLCs. Okay, it is having 8 digital inputs and 6 digital outputs. It is not having any analog input or output devices. Okay, so you cannot connect any analog devices to these PLCs. Okay, so generally these PLCs are called the master PLCs. Okay, master PLCs are main processing unit also you can say. Okay, so the first two diagrams. Now the next two diagrams, DVP16SP and DVP06XA. So these are the extension modules. As I said before, for this PLC or this PLC, you are having a total number of 14 digital inputs and output devices, right? 8 inputs and 6 output. Total 14 input outputs are there. That to digital. Okay. Suppose if your experiment or if your process is having more number of inputs and more number of outputs, okay, more number of digital inputs and more number of digital outputs, so then this single PLC is not sufficient. Okay, you need more number of inputs and outputs for your experiment. So in such a case, you have to add some more input to your main PLC. Okay, so for that purpose you will use the extension modules. Okay, this is the digital extension module, and this one is the analog extension module. So here this is also DVP series 16SP. So now here 16 represents the total number of inputs and outputs. Okay, so it is having 8 inputs, 8 digital inputs, 8 digital outputs. Okay, total 16 IO devices are there. Okay, so now this extension module will be connected to this main PLC. Okay, backside of this you will be having one slot. Under this slot you will place this, right, so that these two are joined together, and total you will be having 14 plus 16, 30 IO devices, IO terminals. Okay, so now if you add the this device to this PLC, you will be having only digital inputs and digital outputs. Okay, so then if your experiment is having analog inputs or analog outputs, right, so then how you can use this PLC? You cannot use. Okay, so in such a case you have to add the analog extension module. Okay, so this is the last one is the analog extension module. Okay, by connecting this analog extension module to this PLC, or backside of this also you can connect. Okay, so then you will be having digital inputs and digital outputs. So here there are 6. Okay, total 6 analog inputs and output devices are there, out of which 3 or 4, right? So 4 are the analog inputs, and 2 are the analog outputs in this extension module. Okay, I think you are understood. Okay, so let us see the data set. You will understand a bit more. So this is the data sheet or instruction sheet of DVP SS2 model PLC. Okay, if you observe the product profile, it will be looking like this. Okay, right, you see here number 1. So number 1, so this one here, so these are the power, run and error indicators. Here you are having 3 indicators. So we one indicator will represent the power, and another one run, another one is if there is error in the instrument, so then that indicator will glow. So 3 indicators will be there, and there is also one run or stop switch. Here you are having one switch, right? So this switch can be kept in a run mode or stop mode. Okay, if you want to make the PLC working, then it should be in running mode, else you can keep it in stop mode, right? So now here the third one is the IO port for program communication, right? This is the RS232. Okay, suppose if you want to upload your program which is written in PC to your PLC, so then from PC to PLC the program will be transferred through this RS232 cable. So this is the RS232 port. Okay, and the fourth one is the DIN rail clip. That means this PLC can be placed on a DIN rail. and fifth one is IO terminals, that means input output terminals. Okay, here these are the IO terminals. So these are the input terminals and these are the output terminals, right? So beside this IO terminals, you are again having the indicators. Okay, so 6 represents the IO point indicators. Okay, so then you are having mounting hole will be there here for extension module. As I said, extension module will be connected to this PLC when you need more number of inputs and outputs. In such a case, that extension module will be fitted to this through this hole. Okay, here you are having the holes. So that extension module will be fixed to into these holes along with this extension port. Okay, if you see the diagram, which I was shown here, see this extension module. If you observe, so this one, this will be kept into that port. Okay, that will be kept into this port, this extension port. Okay, and here you are also having 8 represents the nameplate for a particular PLC, right? Ninth one, as I said, it is the extension port, and the 10th one is the again DIN rail mounting slot, and 11th one, this one is the extension unit clip. That means if your extension module is connected to this one, to make it tightly fitted to this, this is the clip which is used. Okay, and it is also having RS 485 communication port also. So this one is the RS 485 communication port. Okay, and it is also having DC power input, right? So this PLC will work on 24 volts DC supply, right? You have to give the power supply for this PLC. So the power supply will be given from this port. Okay, so now if you observe the electrical specification, power supply voltage is 24 volts DC and maximum ingress current is 7.5 amperes, which is at a 24 volts DC, and power consumption for this is 1.8 kilos, right? As I said before, under this SS2 model, you will be having a relay logic and transistor logic, and this is the standard type. This is not used here, so you are using only relay type and transistor type. Most widely relay type only will be used. Okay, so for relay type, power consumption is 1.8 watts, and for transistor logic it will be 1.5 watts. Okay, these are the electrical specification. If you observe the input and output points specification, right? So under 14 digital inputs and output terminals, 8 are the inputs and 6 are the outputs, right? So these input terminals or input points will have some electrical specification. Okay, so the input port should receive the 24 volts DC. Okay, and inputs will be numbered from X0 to X3 and X4 to X7. Total X0 to X7, which are the 8 digital inputs. Okay, and those inputs can be used either as a sink or a source. So that means you can connect negative terminal to the input port, or you can connect positive terminal. Okay, so in our electrical system, you will be having positive and negative wires. Okay, so you can use you can connect anywhere. Either it can be used as a sink or it can be used as a source. Okay, the input can be used as either the sink or source, and the input current will be 5 milliamperes. Okay, so if your input current is more than this 5 amperes, 5 milliamperes, then there may be damage to your input, and input impedance is 4.7 kilo ohms. Okay, and response time given is less than 10 microseconds for transistor relay logic, and less than 20 for transistor logic. And if you observe the output point, so these output points are represented from Y0 to Y5. Okay, so Y0 to Y5, these are the relay type, so which will having a maximum frequency of 1 Hz. And if you observe the transistor logic PLC, from Y0 to Y5, the transistor logic is also having, so but Y0 to Y3 are 10 kilohertz frequency, and Y4 and Y5 are the 1 kilohertz. Okay, Y0, Y3 are 10 kilohertz, and Y4 and Y5 are 1 kilohertz is the maximum frequency. And working voltage for your output devices is 250 volts AC or less than 30 volts DC. Okay, you have to remember all these electrical specification. Maximum load is 1.5 amperes per 1 point. Okay, 5 amperes per common port. Okay, you have to make sure that the current flowing through the output terminal should not exceed this value. Okay, so for point here is nothing but terminal, right? In Delta PLC, the point is nothing but terminal. Okay, here if you observe here, it is represented output point in the sense output terminal. Okay, that output terminal is having 1.5 amperes maximum load. Okay, and common is having 5 amperes maximum load. Okay, so this is the instruction sheet. You go through this completely to get the clear understanding. I was given only slight overview. Okay, so this is about the DVP SS2 model PLC. Okay, right. How this PLC can be used for a particular application. Let us see one simple example. Okay, I'm taking a simple example, which is an indicator in the sense it may be either bulb or LED connected to a switch. Okay, so if you observe the electrical circuit, one switch is connected to one indicator and one source. Okay, this is a simple electrical circuit. Okay, so now if you close this switch and your Y0 will glow. So a switch is represented with the X0 and a LED is represented with Y0. Whenever you close this switch, your LED will glow. So this is the simple electrical circuit. Now this simple electrical circuit you want to execute with your PLC. Okay, so now whenever you are using the PLC, so first thing what you have to do here is you have to find out the number of inputs and outputs, okay, in your experiment. Okay, suppose I'm taking the example which is in indicator connected to switch. So now in this experiment, what are the number of inputs and what are the number of outputs? Okay, so now if you observe here in this circuit, switch is the input and LED is your output. That means in your experiment there will be only one input and only one output is there. Okay, first thing what you have to do, you have to separate inputs and outputs. Okay, inputs will be connected to input terminals, outputs will be connected to output terminals. Okay, see here PLC connection. So PLC connection, as I said before while discussing the electrical specifications of the PLC, so this X0 pin will be having will be connected to a 24 volts DC. Okay, so here this may be either sink or source. S by S in the sense it may be either sink or source. So these terminals also either you can use it as a sink or source. Now your one input should be connected to one terminal or one point of your PLC. So I'm taking X0 point and connected this X0 point to my switch. One end of my switch, another end is connected to negative terminal. Okay, so then positive terminal of supply is connected to sink or source. Okay, so if you understand this, then you can completely do any experiment. Okay, First thing is you have to separate the inputs and outputs, and inputs to be connected to the input terminals, outputs are connected to the output terminals. Okay, so under this PLC you are having one processor. Okay, that processor will be programmed with ladder programming. Then inside this, these digital inputs and digital output, these are the relay type logic. Okay, I'm using a relay type PLC, right? For the X0 inside this, so if you observe here, let us see one diagram here. So this is your terminal X0. Let us see. Let us assume this is X0, and here upside this you will be having sink or source. S by S you are having. Okay, so inside the PLC, what actually you are having is one connection, which is like this. Okay, so now here, whenever you give 24 volt supply to your X0, so then that X0 contactor inside will be energized. Okay, so that means if you give 24 volts to this plus minus 24 volts, so then X0 will be energized. Okay, so like that other inputs are also the same. So whenever you give the 24 volts DC supply to your input, so that particular terminal will be energized. Okay, right. So now here I am taking the switch which is connected to your X0. Okay, a switch one end terminal is connected to X0, other end is connected to negative of your supply, and positive of supply is connected to source. Okay, so now this, when the switch is in open condition, no power supply will be given to X0, so it will be not energized. Now whenever you close this switch, so then this 24 volt supply will be given to you this X0, then the X0 will be energized. Okay, so depending upon that condition of X0, you have to write the program, right? So you see here ladder diagram. In this ladder diagram, you will be having positive and negative, or rails will be there, right? Now whenever X0 is energized, your output has to glow. So X0 is the input and Y0 is the output. Whenever X0 is energized, then Y0 output will be energized, else it will be in off state only. Okay, so this is the program what you dump into the PLC after writing it in your laptop. Okay, right. What we are discussing here, whenever this X0 is closed, then only this X0 will be energized. So that means you are pressing the switch, we are pressing the switch that is sensed by this terminal. So whenever you close this X0 will get 24 volts DC and it will be energized. Okay, so as per our ladder programming, when X0 is energized, Y0 will be on. Okay, so X0, whenever X0 is energized, this positive supply will go to the negative, so Y0 will glow. Okay, so this Y0 is the PLC Y0. Okay, PLC output pointer. So here also you are having C0, Y0, Y1 like this. Okay, so these are the output terminals. Okay, inside this PLC, the terminals will be like this. So these terminals will be closed or open. Okay, so this will be closed or open depending upon our program. Okay, so here as per this program, whenever you press the X0, that X0 will be, sorry, whenever you press the switch, this X naught will be energized, and whenever X naught is energized, Y naught will on. So that means this contactor will close. Okay, so now whenever this contactor is closed, here we are connecting bulb to your Y naught. Here this is the bulb, so which is connected to power supply. Okay, now this bulb will get the power and it will glow. Okay, so see here ma, your output, this bulb will glow with your external power supply only, not from the PLC supply. Okay, so the PLC will just act like a switches. Okay, the terminals, either inputs or outputs, are the like switches, they are switches. Okay, so inside this, as I said, you are having the contactors. Okay, here like this, you are having one contactor. Whenever this is in open mode, so no supply will be given to your LED, so it will be in off state. Whenever this is closed, okay, through C0, power supply will be given to this LED and this LED will glow. So this is how actually the process will go on. Okay, this is our ladder programming, what you have to write in your laptop or desktop, and you have to dump that into your PLC. Okay, through this RS-232 port. I think you are understood. Okay, you have to find the input devices first, and then in the second step you have to find the output devices. Okay, so then in the third step you have to connect the inputs and output devices to your PLC terminals or points. Okay, inputs will be connected to input terminals, outputs will be connected to output terminals. So then you have to write the ladder diagram program in your PC or laptop as per our requirement. Okay, the program will be as per our requirement. Okay, so then you have to verify the output. So this is the steps which are involved in doing any experiment. Okay, first thing you have to find the input devices, next output devices in your experiment. So then you have to connect the inputs to inputs, outputs to outputs of the your PLC. Then you have to write the PLC program in your software, so that program will be dumped into the PLC through the RS-232 cable. So then you have to verify the output. Okay, in our experiment also we have done the same. Okay, so in our example, indicator connected to switch also, first you have to think about your output first. So what is actually your experiment is. Okay, so whenever I press the switch, the LED has to glow. This is our main aim. Okay, you have to keep that main aim into your brain. So then you have to find out the number of input devices and output devices in that particular experiment. Okay, in this particular example, there is only one input and there is only one output. Input is switch, output is LED. Okay, so then input is connected to input terminals of PLC and output is connected to output terminals of PLC. Okay, as per in this circuit. Okay, so when then you have to write the ladder diagram program in your software. Okay, so which is in your laptop. So then this so this ladder diagram program also, as per our requirement, okay, it will be having two rails, positive rail and negative rail. So but in Delta PLC this negative rail will be not there, only will be having positive, right? So this positive supply in this ladder diagram, So first one, X naught is your in open condition. So this is the open contactor, you can say. Okay, so now this supply cannot go through your output. Okay, so whenever this X naught is energized, then only your output will get the supply and it will go as per our program. Okay, whenever you press X naught, Y naught should energize. Okay, so these all are the software contactors now. This coil is software coil and this is also software output. Okay, so whenever as per your PLC connection, whenever you press this switch, when switch is closed, this 24 volts supply will be connected to your X naught. Okay, so backside this you will be having one connection, sync to sync S by S to X naught. Backside you are having one connection. Okay, like this. So internally you are having one connection like this. Okay, so now whenever this switch is closed, now the circuit is closed. So this 24 volt supply will be given to this X naught and X naught will be energized. Now as per our program, when X naught is energized, Y naught will be energized, right? So this Y naught is also internal to the PLC. Okay, here you are having Y naught. So this is a Y naught, it is a relay type. Okay, so here you are having one internal switch which is of relay type. So this switch will be closed or open depending upon this Y naught coil. Okay, whenever this X naught is energized, Y naught is energized, so Y naught will on. Okay, so now this supply will be connected through this C naught Y naught to bulb. Circuit is closed here and the bulb will glow. Okay, I think everybody understood. If you are having any doubts, you can comment in the chat box. Okay, thank you.